Okay, so the next one is the square function, f of x equal x squared, or y equal the square root of x, f of x equal the square root of x. The domain of the function is the set of all x such that x is greater than 0. Okay, so I can't take the square root of a negative or the square root of the square root of 0 is fine. I get 0. The square root of a positive is fine, but I can't take the square root of a negative. The range of the function is the same. Set of all y such that y is greater than 0. So if I take the square root of a number, I always get a positive value, or a non-negative number, I should say. 0 is neither positive nor negative. But like the square root of 9 is 3, the square root of 16 is 4. Okay. Are we increasing or decreasing? So we're increasing on the interval 0 to infinity. The curve is constantly rising on the interval 0 to infinity. Okay, now the next one is the cubed root function. F of x equals the cubed root of x, or y equal the cubed root of x. Is the same thing. The domain is all real numbers, and the range is all real numbers. The intercepts is at 0, 0. Okay. Increasing or decreasing? You're increasing everywhere on the interval negative infinity to infinity. So even right here at 0, 0, there'd be a vertical tangent, and you're still going to be increasing, since the number to the left of 0 is going to be some negative value. The number to the right of 0 is some positive value. And 0, 0 is an intercept, but 0, 0 is still going to be a point where you're increasing. Okay, the reciprocal function y equal 1 over x, f of x equal 1 over x, same thing. The domain is x, set of all x such that x is not equal to 0. The range is the set of all y values such that y is not equal to 0. In other words, what's happening on this graph is that the curve is approaching the two axes, but it's never going to get there. Okay, I know I can't divide by 0. Division by 0 is not allowed. If x is 0, that would be the one and only number that would return y equals 0. And x can't be 0. So what that means to us is that we've got a vertical asymptote at x equals 0, and x equals 0 would be a spot on the graph where no graph would touch, and y equals 0 would be a spot on the graph where no graph would touch. Okay. The intercepts are none, so at no point will the graph cross or touch the coordinate axes. X can't be 0 and y can't be 0. Okay, are we increasing or decreasing? You're going to be decreasing everywhere except for 0. X can't be 0. But in other words, if I draw a tangent line to the graph, the tangent line is going to have a negative slope no matter where I draw that. Just make sure that you're not including 0. Okay? And the absolute value function is a v-shaped graph. Y equals the absolute value of x is the equation. The domain is all real numbers. So I can take the absolute value of any number I want. The range is the set of all y's such that y is greater than 0. For any value of x, the absolute value of a number is never going to be a negative. Okay. The intercepts, the one and only, is at 0, 0. And it looks like we're decreasing on the interval negative infinity to 0. And then we're increasing on the interval 0 to infinity. Okay. Again, make sure that you're not including 0 as the an intercept. Okay. The next thing to talk about is the average rate of change of a function, and that is defined to be f of b minus f of a divided by b minus a. So here's an example. Let f of x be equal to 0.5 x squared plus 50 represent the outside temperature in degrees Fahrenheit at x p.m., where x is ranging from 1 to 5. Okay, find the average rate of change of f from 1 p.m. to 4 p.m. Well, let me use this formula. So b is always going to be the bigger number. 4 is bigger than 1, so b is 4. F of 4 minus f of 1 over 4 minus 1. F of 4, 0.5 times 16 is 8, plus 50 is 58, plus f of 1, 0.5 times 1 is 0.5, plus 50 is 50.5, divided by 4 minus 1 is 3. Okay, 58 minus 50 is 7.5, divided by 3, you get 2.5 degrees Fahrenheit per hour. Okay, now one of the things that I care about is whether or not this is a positive or a negative number. This is a positive number. Okay, so the average rate of change from 1 p.m. to 4 p.m. is 2.5 degrees Fahrenheit per hour. Or the temperature increased on average by 2.5 degrees Fahrenheit per hour. Okay, here's a picture. Here's 1 50.5 and 4 58, 2 52, 3 54.5, and I've got my curve here. Now, f of 4 is right here. F of 1 is right here. And I draw a line. Now the slope of this line is 2.5. Okay? So the average rate of change is the same as the slope of a line passing through AF of A and BF of B. Now you'll notice this break in the graph here. You can include that if you want, or not if you don't want to. But usually that's going to be part of the graph if you're not including 0 as the start point there. So now okay. What if I was going from 1 a.m. to 4 a.m.? Okay, because this is p.m. What if it's a.m.? Well, what would be the average rate of change? Well, more times than not, it would be a negative number. Okay, so you think about of how the average rate of change of degrees Fahrenheit per hour increases or decreases in the 3.5 hours or 3 hours from 1 a.m. to 4 a.m. I mean, more times than not, it's 1 a.m. to 4 a.m. is going to be some negative number, some negative slope. So really, the thing that I want you to notice is that this here is the formula for a slope. Okay, and that's what we're interested in. If the slope is a positive, or if the slope is a negative, then, well, we don't really care what happens from 1 p.m. to 4 p.m. It could go up and down and up and, it's changing on an average of 2.5 degrees Fahrenheit. Okay. All right. Let's stop right there.